Welcome to Calculus. Today we will investigate finding derivatives from graphs, focusing on applying the product and the quotient rule when I don't have an equation, but simply a set of graphs. We'll take a look at three different derivatives. One that involves the product rule, one that involves the quotient rule, and then one that involves a corollary to the quotient rule, which we call the derivative of the reciprocal of a function. Well, let's take a look at the representation of our functions that we have here. So we're given a graph that's composed really of two main functions. So the upper one here, this piecewise function that has three different linear parts, that's f of x. And then this lower function, upside down v or a mountain, is another piecewise function, g of x, that has two linear parts. We're also told that the function u of x is equivalent to f of x times g of x. So that's our product rule that we see kind of implied there. And then v of x, which is f of x divided by g of x, that's implying our quotient rule. So let's investigate this first derivative. It's the derivative of u, so u prime at -4. So since we're working on a graph and we don't have access to equations, one thing that might help us is to actually write our equations, which will help us when we go to calculate the derivative of the product. So let's start over here on this left side, and let's find the equation of this left-hand piece. So I'll just kind of roughly outline there in red. So that one, if I extend it, I can actually see where it's crossing the y-axis. And I see that its slope is really down one, right one, down one, right one. So that line, I can write its equation immediately from that information. It's got the slope of -1, so y equals -1 x. And then it's crossing the y-axis here at +1, so +1. And that's our mx plus b equation for that left-hand side of f of x. Well, this middle piece is perfectly horizontal, so it's got a slope of 0. I could write it as y equals 0x plus it goes through the y-axis at 2, but 0x will cancel. This is y equals 2. And then the last piece here of our upper f of x is this right-hand linear piece that's got a positive slope. So we'll calculate its slope first by counting. So it's up 2, and then to the right 1, 2, 3, 4, 5. So its slope is 2/5. I don't know its y-intercept. If I trace down, I'm seeing that it's crossing at some decimal. So that I need to calculate. So I'm going to just put plus b. And then to help me find that value, I'm going to substitute an x and a y. So I see I got a point here, 1, 2. So I'm going to substitute 1. So I see that's on that line. So it's part of that function. So I'll put 1 for x and 2 for y. And then I need to just solve for b by subtracting. Remember, 2/5 has the value of 0.4. So I'm going to subtract 0.4. That'll cancel here on the right. And that gives me a y-intercept of 1.6. And that looks about right from my estimate where it's crossing the y-axis. So what I'll do then is I'll return my variables. And for b, I'm going to write plus 1.6. And that gives me my equations for those three pieces to my f of x, that upper function. Let's do something similar for my lower g of x. That has two parts, so I'll start here on the left. It has a slope of 1, 2, 3, 4, 1, 2, 3, 4, 5. So its form is going to be y equals 4/5x. Then again, I don't know its y-intercept. It's crossing here at some decimal value. So I need to calculate that same way as we did for that upper part on the right of f of x. So the point that I'll substitute in here Let's put in this close point, -4, -3. So that's -4 for x, -3 for y. And we just need, again, to calculate this. So that's going to be -3 equals -16 over 5 plus b. I can convert -16 over 5 to a decimal. That's -3 and a fifth would be 0.2. So as I solve this, I'm going to add 3.2 over, cancels there. And then -3 plus 3.2 is simply 0.2. So that's my b value. And let's write this equation. Again, I'll return the y and the x and the y-intercept of 0.2. All right, just one piece left here. So the right-hand side of g of x here. So I'm going to get rid of these extra marks. And just to check there, that does look about 0.2. That seems like a good y-intercept. All right, last piece. We'll start again by finding slopes. I'll start at that point 1, 1, 1, down 2, down 3, down, oops, too far, down 3, 1, 2, 3, over 1, 2, 3, 4. So its slope is going to be -3 over 4. If I put that in its form, again, I don't see directly where that's going to cross y-axis. I can estimate too, but I doubt that it crosses right at that integer. So let's again use our strategy where I take a point, substitute in. So I started from the point 1, 1. That'll work. So 1 for x, 1 for y. Again, that's the point there on that line. So when I go to solve this for the b value, it's 1 equals -3/4 plus b. Add 3/4 to both sides. And we see that our b value here is 1.75. So again, I'll go back. I want that y equals mx plus b form. Y equals -3/4 x plus 1.75. And that gives me my equations to these 5 parts on these piecewise functions. So I'll just clean up. And what we're ready to do is start applying our product or quotient rules here to this calculate u prime at -4. So again, I'm going to identify u prime is a derivative of u of x, and u of x is the product f of x times g of x. So what I need to remember is what's the product rule. So let's write that so we can see it again. So the product rule, if I've got a function big f of x is small f of x times g of x, so just like our u of x, its derivative of big f of x is going to be little f of x times the derivative of g of x plus g of x times the derivative of f of x. So what we need to find are those 4 parts. What's f at -4? Let's set out what we need to find. F at -4, which will go here. We need to find also g at -4, which we'll put there. We also need to find the derivative of f at -4. And lastly, the derivative of g at -4. So those 4 items, and then once we get those numeric values, we can plug into our product rule. So let's find what we're looking for. So I'm going to use the equations. So I just need to find which pieces I'm working on. So f is the upper function. -4 is out here, the one we've outlined in red. So I'm actually in luck. I have the point negative 4, 5 right there, just to show how I could find it. I would plug it into the function negative 1x plus 1, that equation we'd written over there on the left. So that'd be negative 1 times the x value, negative 4, plus 1, which would be 4 plus 1, or 5. But we could have seen that y value was 5. Well, in any case, we've got that. Let's then take our attention over to the derivative of f at negative 4. Actually, let's switch here. Yeah, well, let's find the derivative. So what we got to think here really is just in terms of a graph and a line, what the derivative would mean about the line. It's really the slope of the line. So I'm going to put here that it's the slope of the f function over there at negative 4. And I can see from my mx plus b equation, slope is negative 1. All right, so let's then calculate g at negative 4. So that's g, that's the lower function down there in green. And the left-hand side, because we're at negative 4. Now I can see already I've got that value at negative 3. I can confirm by plugging it into my equation. So it's 4/5 times negative 4 plus 0.2, which is going to be negative 16 over 5, plus, if I reconvert to a fraction, 1 over 5. So that's negative 15 over 5, which is negative 3. All right. And then again, what's the derivative of g at negative 4? Well, that's that slope 4 over 5, which has the value of 0.8. So we're ready to plug stuff in here. In fact, I'll use the fraction there for that one. So again, I'm going to plug in to my product rule. So let's put our notation. The derivative of u at negative 4 is going to be, so we'll color code this, f at negative 4, and negative 4 is 5, times the derivative of g at negative 4, so that's 4 over 5, plus the value of g, so the function value at negative 4 is negative 3, times the derivative of the f function, the slope of that left-hand line on the upper function is negative 1. And then we just need to simplify. So my 5's cancel there. This is 4 plus negative 3 times negative 1 is 3. This has the value of 7. So we did a lot of work there to set up our line equations. Let's work from those same equations. So here I've got the equations already written. We don't have to redo that step. We want to now calculate the derivative of v at positive 4. So I'm going to highlight the v function. That's this f of x over g of x. So if we think, what rule does that imply? Well, that's the quotient rule. So let's remember what quotient rule says. If I've got big f of x as the quotient of small f of x over small g of x, then the derivative of big f of x is this rule. So it's going to be g of x times f prime of x, the derivative of f of x, minus f of x times the derivative of g of x all over g of x squared. So a little more complicated. It does involve minus, so our order is important in the numerator. But then again, I've got my pieces. So I just need to, again, lay it out so that I can see what's what. So let's start with our f of x again. So here I'm interested in the value of the f of x for the upper function at positive 4. So that's this line in green, right about here. That looks like about 3 point, I don't know, 2. Let's calculate it though. So I got my formula, it's 2/5, putting in 4 for x, plus 1.6. So that's going to be 8/5 plus 1.6. And again, 8/5 is going to be 1.6 plus 1.6. That's the value of 3.2. So pretty close to what I estimated there. Let's also find the derivative of the f function at that same x value. So again, what we're saying there's what's the slope? It's 2/5, which has the value of 0.4. All right, so let's then calculate for our g function, the lower function. So g of x, and I should say not g of x, but g of 4, has to do with this right-hand line. We'll outline it in red. So we're looking at first, what's the function value? Is that negative 1.2? Let's see, 1.25 maybe. We'll use our rule there. So it's negative 1/4 times 4. Again, I'm getting this rule from what we wrote, plus 1.75. So that's going to be negative, my 4's cancel, so negative 1 plus 1.75, which is going to give me (0.75). Let me correct an error I'm seeing there. So I see I wrote that this is negative 1/4. It's negative 3/4. So how does that affect our calculations? Let's just track it. So that's going to be a negative 3 instead of a negative 1. And that's going to change my sum here. So negative 3 plus 1.75, that's negative 1.25. Okay, good to check that. And then finally, the derivative of g at 4 is the slope of that line, so negative 3/4 or negative 0.75. So we're ready to set up for our quotient rule to calculate now. So again, I'll just put the notation there. We're calculating the derivative of the v function at 4. And we'll just plug into our rule and then we'll calculate, probably using Desmos. So g at 4, which comes first, is negative 1.25 times the original f function, which is 3.2, minus the derivative. Oh, let me fix that error. So again, it's good to see this should be the derivative of f of x, 0.4. Caught it. Minus the original f of x, there's my 3.2, times the derivative of g, negative 0.75. And that's all over g, which is negative 1.25 squared. So that's set up. Let's go ahead and write that down, and then we'll calculate using Desmos. So I'll just take a moment to record it. We could take the time to calculate here, but lots of parts in, the calculator's a good tool. Let's use it. So let's head over to Desmos. And do our calculations. So we got a fraction, I'll hit divide, and then with our parentheses in the numerator, negative 1.25 times 0.4 minus parentheses 3.2 times negative 0.75, and that's all over with parentheses, negative 1.25, close parentheses, squared. And that gives us the value of about 1.216. So we'll head back to our note screen to finalize that one. And let's take a look at one more example. So I will finalize this. This has the value of 1.216. So our last example, if we scroll down, has to do with a reciprocal function. So I see here that I'm looking for the derivative, so d dx, of 1 over f of x at x equals 2. So notice it doesn't involve the lower function at all. It's just this upper f of x piecewise function. But we need some kind of rule for this. So this is called the corollary, the derivative of the reciprocal of a function. So let's define that. So derivative of reciprocal of a function. So you can see reciprocal is just f of x flipped over to 1 over x. So here's the way that the rule goes. If I've got a function 1 over f of x and I take its derivative, so d dx of 1 over f of x, the way that I take its derivatives according to this pattern, it's negative derivative of f of x in the numerator over the original f of x squared. So it kind of has the look of our quotient rule, but it's modified. Notice that the numerators only got the 1 term instead of the 4 terms and the difference. So really only 2 things to find here. We need to find f at 2. So since we're over here at 2, we're on this right-hand line. So we're going to calculate that that's 2/5 times 2 plus 1.6. We'll calculate that out. So that's going to be 2/5 is 0.4. So that doubled is 0.8 plus 1.6 is going to simplify to 2.4. We also need to calculate the derivative of f at 2. So again, what we're saying there is what's the slope? Well, that's my 2/5 or 0.4. So a lot of work that we had done writing the equations just makes this calculation a lot quicker. So those are the only 2 parts that I need. So at this time, all we got to do is plug in and calculate. So let's set it up, and we just want to be careful with our notation. So the derivative, here we're using the Leibniz notation, the d dx of 1 over f at 2 is going to be negative. So there I want the derivative of f of x, which is 0.4, over f of x at 2, 2.4, and that's squared. So again, there's my setup. All I need to do is calculate that. So negative 0.4 over 2.4 squared. Let's head over to the Desmos calculator to get our decimal answer. It's a fraction again, so negative 0.4 over 2.4 squared. And that gives me the repeating decimal, negative 0.069 repeating 4s forever. And let's go record that. So final answer here, negative 0.0694 repeating. Well, thank you for joining for this look at taking derivatives of functions from graphs using the product and the quotient rule, and this new rule for us, the corollary, which is the derivative of the reciprocal of a function. I'll let you go differentiate your own functions represented by graphs. See you soon.